Next, we have a exploitation demo by Alberto Rodriguez, who goes around us by A-Rod. A-Rod and his wife recently had a second baby, so while he was with us today, he could not make our rehearsal, so he kindly recorded his talk, and we are in for a treat. Let's see this play.
Hello everyone, and welcome. Thank you for tuning in to this talk. I'm going to be giving you just a very, very quick high-level rundown on Kubernetes security. We're going to actually spend a majority of the time looking at demo style learning. So, we brought together sort of a realistic scenario for you to take a look at how Kubernetes could be targeted and exploited out in the wild. So, who am I? My name is Alberto Rodriguez. I currently work for a company called 6gen, where I'm the director of cyber solutions, and I'm also an offensive operator for the company. I ultimately wear a couple different hats for my company, and on my spare time, I'm also a technology mentor here at Project Reclass. So I'm very excited to have you guys here and listening into our hack day and listening to my talk. So I thank you for your time. I also teach on the side at formerly HackerU, a company called Thrive DX. I'm a lead cyber instructor where I teach various different cyber things. My background is really, military cyberspace operations and, the classic threat hunting, penetration testing, that type of stuff. Just to touch on, really appreciate the team here at Project Reclass for allowing me the floor for a few minutes to give you this conversation. I really appreciate the opportunity to be able to touch, different aspects of the veteran community, especially the great mission set that Project Reclass sets out to do. Really love helping out, veterans transition from the military. So if any vets are listening in and you want to reach out to me, about tech, about cyber, just about your transition, please do not hesitate. I'm more than willing to have a conversation. And this is a recording, so I do apologize for not making it live. My wife decided to, have a baby a little bit earlier than expected, but all is well. So again, thank you for listening, and let's dive in. So Kubernetes security, here's just a quick agenda. We're going to do a quick intro. We're going to talk about infrastructure, some quick wins for you if you're responsible for securing and configuring a Kubernetes infrastructure. And then we're going to jump right into the demo side of things. All right. And then we'll finish things off with some resources and open it up for any questions. And we'll be able to use the chat to answer those questions accordingly. All right. So why are we talking about Kubernetes, particularly Kubernetes security? So this is a recent blog article. I tried to find the most recent one, but essentially with Kubernetes being a very popular technology for infrastructure as code, application development, really that forces our attackers to shift their focus, force them to retrain, force them to understand the latest technologies, because that is what their victims or their targets are going to start using. So here, a very recent article about how, these threat actors are starting to target Kubernetes to steal data, to conduct, their operations. So we're going to talk about, some of the implications from the security side of things for Kubernetes. And to kick things off, let's talk Kubernetes as a whole, right? So this is software that runs on your system or on your server. And a lot of companies, particularly AWS, Google, DigitalOcean, Azure, etc., they have Kubernetes clusters almost as a service, to where it's very easy for anyone to spin up infrastructure, configure their applications, and get moving. Just remember that patching that software is important. There has been numerous different reports on Kubernetes itself as a software having high severity vulnerabilities. So making sure you're running the latest version of Kubernetes is essential. Second line item here is that Kubernetes API. So remember, this API interacts with ultimately all the different aspects of the Kubernetes cluster. Securing, a secure configuration means multiple things. It means ensuring that the right access control to that API has been, configured. Additionally, you don't want to expose the Kubernetes API to, let's say, the public internet, right? You want to make sure that that Kubernetes API is exposed to the right place. Typically, you want to do some network segmentation. You want to do some access control to ensure that that API is being adequately protected. Secure etcd. As a reminder, this is, sort of a key value store used by Kubernetes to access data. It's sort of considered the truth for Kubernetes. You can read data, you can write data into it. So just make sure that all communications are being served over TLS, which I bring again towards the end. Secure the kubelet. So, as a main mode agent running on each node, misconfiguring Cubelet can actually expose you a sort of a backdoor access, right? So make sure that you've disabled anonymous access to the Cubelet. Make sure you're starting the Cubelet with that anonymous off equals false flag. So you ensure that you're leveraging the node restriction admission. And just as a fair, disclaimer to everyone, this isn't the only component you should be aware of. Obviously, we're a bit time constrained, but make sure you're accounting for the security of the kube scheduler, the kube controller manager, and those configuration files that go to the master and the working nodes. I mark down TLS everywhere, right? Very important. You want to make sure from your consumer to the load balancers or the front end, all the way to the back end and all in and out, you want to make sure there is TLS everywhere, because what happens is a lot of people have TLS from, let's say, the consumer to the load balancers, and then from the front end to the back end, it may not be encrypted, right? You may have clear text traffic, HTTP. So make sure that everything is encrypted, because if an attacker is able to get into any part of the application workflow and just take a look at that traffic, you could be passing some very sensitive data across the wire. And then the final bit here is just make sure that from the ground up, as your developers are building these applications, you are building them as non-root containers. What that means is don't take the easy way out as a developer, as an organization, and run your containers with high privileges, because this could come back and haunt you. By giving root privileges to an attacker that's able to get access to your system, they can ultimately do a lot more in comparison to being a low privileged user. All right, let's jump into some quick wins, okay? Minimal base images. So pretty standard. The less you have in those images, the less chance for vulnerabilities, right? Make sure you are scanning those images to identify known vulnerabilities. So you should always be scanning your vulnerabilities. Integrate that security, integrate the scanning into your CI/CD pipeline. So as you're pushing code, whether you're a developer or a security practitioner, that code must be scanned, must be analyzed in an automated fashion to account for human mistakes, to account for secrets being put where they shouldn't be, et cetera, et cetera. All right, make sure you implement a defense in depth approach. We're talking access control, network segmentation, least privilege, patch your application, make sure the dependencies that you're using are patched as well. There's just a lot of different things. As we talk about defense in depth, you just want to make sure you account for that in this Kubernetes style of an environment. The last piece there is to use those network policies to really control the traffic between the pods and the cluster. And then just watch your secrets, right? Secrets, they're sort of all over the place where you're doing infrastructure as code. But these Kubernetes secrets maintain sensitive information, such as passwords, OAuth token, SSH keys, et cetera. So storing the sensitive information can provide greater access control than just storing passwords or tokens in like a YAML file or a container image. As a reminder, Kubernetes itself stores secrets as an unencrypted base64 encoded string, which can actually be retrieved by anyone with API access. So again, this goes back to securing the Kubernetes API. That access has to be restricted by applying the role-based access control policies to the secrets resource. So again, watch those secrets. All right, cool. So we're gonna start with some hacking time, okay? We're gonna jump into a little bit of the slides, and then we're gonna jump back and forth between some demo and some slideology. All right, so the anatomy of this attack, we'll start with the first phase, phase 0 here, which starts as in the traditional sense with enumeration, right? We're conducting passive enumeration, active enumeration, performing open source intelligence on our target. And for the sake of this demo, we're just going to pretend that this specific breach that just occurred, I believe 11 August, if I'm not mistaken, Accenture, which is a pretty big firm, had a data leak, right? Within this leak, you can see in the screenshot here, there were some credentials. So for the sake of this demo, we're gonna pretend we're some threat actor. We're able to open source intelligence, gather open source intelligence from an organization and get a valid set of credentials. All right, once we get a valid set of credentials, we finish our enumeration phase, we're gonna move into the second phase, which is get first access into our system, into our vulnerable target. So for this specific scenario, we're going to use GitLab, a vulnerable version of GitLab, which is a code repository, and we're going to get some code execution on that GitLab server, which is public facing. Once we have the operating system access, we're going to get access to some VPN configs, and you'll see what we're able to do with that later on. So let's jump right into the demo here. Here is Mythic, which is a command and control framework. It's open source. You can check it out. I put it at the end of the slides in the resource. And I'm going to use an implant called Poseidon, okay, open source as well. Poseidon is a fully featured Linux Golang agent. This will serve as my implant that I'm going to put on the target, meaning the GitLab server. Now, all of these communications will be over HTTPS, leveraging that web protocol so it's able to sort of blend in with the traffic. As you can see, I have no active callbacks, meaning I don't have any agents in this specific server. So here is our vulnerable version of GitLab. Okay, welcome to DevCorp. Again, we were able to gather some credentials. So, I have the root user, and I'm going to enter that password that I gained from the dark web, from the leak, etc. All right, one of the first things I'm going to do is, first I'm going to celebrate because they worked, right? So I'm going to say yes. All right, cool. After my celebration, I'm going to take a look at what's inside, what's in the purview of access for this specific user. Okay, so there are some internal docs. I'm going to check out every single project they have. Maybe I can get lucky, right? We're looking for SSH keys, config files. If you're just interested in proprietary data, maybe I'm going to steal the entire source code for an application. And I can also come across some creds. All right, right? So I'm able to find credentials within a test Blippi application, okay? And I'm also able to identify a username. So awesome. I'm going to head over to Mythic, and I'm going to add these credentials in my notes, okay? As operators, your threat actors are going to keep very detailed notes of what they experience because they never know when something's going to come back and help them out later. Here is me fidgeting with some words, and there we go. Okay, so I'm able to put the password here, awesome, and I'm able to mark that down maybe for later use. We'll see how we see that. Next thing I'm going to do is check out the GitLab version. Okay, I need to know the exact version running of this server. As you can see, it's telling me I should probably update. So I'm going to do some research, and I'm going to say, okay, tell me from this 13.9.3 version, what exploit is out there? And I'm able to find a remote code execution vulnerability that requires a valid set of credentials. Lucky for me, I have one. So I'm going to grab this code, modify it a bit, and I'm going to try to get code execution for this specific user. Okay, just to showcase here, I'm actually hosting the implant. I'm hosting that Poseidon implant on my malicious server, so I can pull it down. As you can see here, I'm going to run Python 3 exploit. I'm going to curl, meaning I'm going to download that file over. I'm going to move that file into the temp directory. I'm going to call it linupdate. I'm going to give it executable rights, and I'm going to execute that file in the background. So as soon as I execute that, it's going to ask me for some credentials, which again, we have and we know based on, open source intelligence. And as soon as I trigger that, as you can see on the right there, I get a callback. Okay, so I'm going to take a look at my active callbacks. There you go. We have a callback on this host called GitLab SRV. If I do get user, I am running as the get user. And as you can see, the architecture is Linux for this specific implant. So because I have this implant working now, I want to, perform some further enumeration. As you can see at the bottom there is an indicator of compromise to the defenders involved. Okay. So let's take a look at what's in the root directory. All right. Maybe this is misconfigured. The system administrators don't pay too close attention to how they do file permissions and folder permissions. So I'm just going to sort of fast forward here. We're actually going to download a VPN config. There's also this interesting file called jumpbox IP, which again, pretty standard for system administrators to use. Just a jump box to conduct their activities, and we're able to get a user and an IP address. So again, from a note-taking perspective, I want to get some of that onto, my documentation path. So here we go. We have that readily available for us. We're able to get the IP that may be of interest. We have a set of credentials that may work somewhere. And we have this VPN configuration file. So, spoiler alert, we're going to actually VPN into the network because of this specific configuration file. All right, let's jump back into the slides. Now that we've got that initial access, okay, we've exploited GitLab server. We have access to the operating system. We have the VPN config. The next thing we're going to want to do is actually perform some enumeration. Okay, so my team is behind me, right? I'm a hacker. My team's behind me. They're playing along with me, and we have to do some recon. So let's go ahead and jump into some recon here. And this is, pretty standard stuff. I'm able to log in. I have the VPN config there, and I'm just going to quickly use OpenVPN to authenticate over to that VPN. As you can see, I have a new interface called ton0 with the 10.8.0.2 IP address. So awesome there. And I'm just going to quickly perform an ICMP scan. Okay, I'm just going to go through 1 through 5 just for the demo's sake, and I'm able to identify new host. Okay, after I identify host, I'm interested in this .3 because that was quote unquote the jump server, and it's a little bit interesting to me, right? So I'm going to do an mmap scan. I'm going to verify that it's running SSH, and then I'm going to do a deeper port scan. And as we do some analysis of this port scan, you're going to notice, within the fingerprinting, right? You're going to notice some information about it, and it looks like this could be a Kubernetes cluster. Okay. And this is based off a DNS running on a specific port. There are signed certificates, self-signed certificates that are leaking that are able to give us some information about the server. So we have a target, okay? The next thing we're gonna wanna do is access that Kubernetes cluster, okay? We're gonna try to see if we can log in maybe with the credentials that we received. So let's go ahead and try that, all right? From a logging in perspective, we can see that that specific IP is actually hosting some applications, all right? So from a security perspective, we VPN'd in, we have access to, the network once we're inside the VPN, and we're able to access this internal application. As you can see from the internal application, they are using some, poor practices, meaning chatting credentials to one another. Okay, so again, as an attacker, I'm going to do my job. Get some interesting error message, disregard that. And I'm going to annotate these credentials for later use. Again, you're starting to see the theme here, kind of a rinse repeat method. All right. And again, I'm taking a look at this chat back application. I notice this user called Michael needs a status of some inmates before close of business. So again, Scott's asking what their names are, and Michael says, I can do one better. I'm going to give you their socials. So maybe, interesting, right? So again, these are just poor practices by employees. These are things that we see out there on the wild. These are mistakes that maybe your organization is not aware of, but specific individuals do sort of account for it. All right. So again, I'm just going to store this sort of in plain text, and I'm just going to, again, annotate these social security numbers. Not the best copy pasting here, but I think y'all get the picture as to what I'm after from an attacker perspective. All right. So the next thing I'm going to do is I'm going to try these credentials that I have. Okay. Maybe those credentials that I got from the test application will work. Maybe there's an admin that likes to reuse their passwords quite often, which is definitely the case here. All right. So I'm going to try to authenticate as this admin. I get the password wrong that first go around. And then let's see if I get it right this third time. And then awesome. I am in this server as admin 1. Remember, I got on the server from the credentials that we found on GitLab, okay? Hard-coded credentials on GitLab could be dangerous, all right? So here we take a look. It looks like the host name for the server is Kubernetes cluster. We take a look at the running ports, and there's just a lot going on. If you can see, there's a lot of ports listening on localhost. Some are listening on the public interface of this. So again, it's a very interesting finding, but as an attacker, I think I want to get persistence on this Kubernetes cluster server as well. Okay, so I'm going to do the same exact thing as I did before on the GitLab server. I'm going to go ahead and pull down that implant, the Linux implant Poseidon, and I'm going to, there we go. I just do a quick sleep condition so I can jump over to the command and control framework. And as you can see, I have a new callback coming from the Kubernetes cluster host, okay, 10.8.0.3. All right, if I do print working directory, there I am. So now I have access to 2 different servers. I've compromised the Kubernetes cluster. I can essentially compromise every single server running on it. I can take a look at those running services, and this all starts, from a specific point in time, which was getting access to a vulnerable public-facing application, right? Which again, pretty common sort of thing. So I hope you enjoyed the demo. I'm a bit on a time crunch here, but just want to leave you with some final resources. About a week or so ago, as of the time of this recording, the NSA dropped an amazing hardening guidance for Kubernetes. I highly recommend you do a quick Google, you check that out, you do some reading. Obviously, Kubernetes.io will have great security sort of guidance for you as a developer or a user of Kubernetes. There's the command and control framework that I use, which is Mythic by developer. His name is Cody. Also, feel free to check out Red Cube, which is an offensive tool for going up against Kubernetes. There's also a Kubernetes GOAT repository there if you want to learn some of these offensive tactics. And there's also a Kube Hunter repo, which is there at the bottom. And it's great for finding Kubernetes like misconfiguration, weaknesses, etc. All right, so I'll leave you with those resources. I do thank you for your time. I appreciate everyone's attentiveness. You can always reach out to me on Twitter, _AROD_ with a 0, or feel free to reach out to me on LinkedIn. Thanks again for listening. I hope everyone has a wonderful rest of your day. Goodbye now. Hello, everyone. And
Wow. And that's a wrap.